so forth, because our professor at U Chicago, director of the data science institute. Before that, he was a full professor at Princeton, and before that, he was a full professor at Georgia Tech. I think many of us here have known him for a long time, and also more importantly, collaborated with him. Really very fruitful collaboration. One of the colleagues that is the most. So.
Great, thanks for the opportunity to visit. As I was saying to Rich right before and Wenki, it's actually really a privilege to be back here speaking to you. I think I gave a version of it like a couple weeks ago as a keynote. I kind of threw it together, but then I was like, I've got to come here and give it to my friends. So I was like, I put a lot more work into prepping this version. So I hope you enjoy it. And as I was saying earlier, it's actually really nice to be back talking on this topic. This is actually not a security talk, so sorry. But this is actually work that I started here at Georgia Tech. And so it's really nice to be back to talk about work that actually I continue to do. This has really, it's actually, this worked a minute ago. Right, so I included a fair number of pictures in this to keep it interesting too. So actually this work started at about, I think I was maybe still assistant professor here at Georgia Tech. This person here pictured Renata Teixeira. She's actually she was not a Georgia Tech person, but one of my closest collaborators at the time. And as I mentioned, I'm still working on this, and I think it's really kind of interesting that a very, very simple question has really shaped a big arc of my the work in my career, and it's been very fulfilling. The question, as you can see, this is pulled from about that time. I couldn't find the original, but how can I monitor my ISP connection quality over time? This really simple question was like, what's the speed that my ISP is providing to me? And does it match my, the advertised rate? And you'd think, well, like speed testing, that's actually pretty easy, right? All you're trying to do is measure like how many bits you can push across a wire in a fixed unit of time, bits per second. Like what could be simpler? Well, I don't know. 15 years later, I'm still working on this. So. And for the next hour, we're going to talk about it. So I'm going to show you it's like not that easy. It's actually quite interesting. But actually, here's kind of how it started. Was Renata was at CNRS, researcher in France, and she said, "Yeah, this is a really interesting question. And there's actually this project in France called Grenouille. I think it translates to frog or something like this. And they're like they've got this really interesting data set on like they basically got people measuring their ISP speeds." From all over France, and I actually have access to data sets. It's really cool. We're going to basically write a few Perl scripts. Perl was the thing back then. Write a few Perl scripts, like generate some plots, write a paper, and then what we've done with it will be really easy. And then so we got this data set, and it was like a mess. Okay, there were like negative latencies and other things like that. We did clean it up, and we eventually got a paper out of it. But it actually led me to this conclusion that like, wow, actually, internet measurement is not that easy, right? You can get a data set, but as we know these days, data can be pretty dirty. And if you don't look at what you're getting, you don't control the circumstances under which you're gathering that data, you're going to end up with a mess that wasn't of your own making and actually be very hard to draw conclusions that you want to draw. And so quickly I concluded that we basically needed to build the thing ourselves, like design and build the measurement infrastructure ourselves. And that's kind of taken me on the journey that I'm going to tell you about. This was a plot like from the original paper like that we wrote on the topic, which factors affect home network performance. And I don't even have these slides anymore, but I found it somewhere. I gave this in 2012. And this was basically plotting like, essentially download speed. And this is like a CDF. So if you're not familiar with that, it's basically an integral of a histogram, right? But the thing about like to observe from this was that like, if you look at these 4 different ISPs in France, there was like this widely varying performances in the data. And we were like, we have no idea why. Absolutely no idea. Like, could have been like the operating system, could have been the host, could have been like 50 factors. And we just had no idea. And this is where I concluded, like, we just have to base something's going on here. This data has some interesting variability, but as a scientist, I really can't explain anything about what I'm seeing. So like, let's go build it. Let's go instrument things. And that's kind of taken us on a journey. I'm going to come back to this question like several times in this talk, because I'm going to start like at the network layer, moving bits across the wire. This talk's going to end with internet equity, digital divide kind of issues. Why do we care about any of this, right? So, well, ultimately, I was just kind of like a networking nerd. I just wanted to measure stuff. I thought that was, pretty interesting question. Let's just like measure how fast the network can go. And then, as I got older and I gained some more perspective and, ran out of things to work on there, I was like, well, actually, yeah, that's an interesting scientific question. But ultimately, what are we trying to do here? We're actually trying to make the world a better place. We're trying to basically improve the state of the network for the people who use it, right? So the question of like measuring speed is an interesting one because at the time, especially like in 2010, 2012, that was the thing that affected the lived experience the most. Like those of us who were old enough to remember the internet at that time remembered that our ISPs kind of sucked. And so running a speed test was the thing to basically tell you about the lived experience. And that has changed over time. And that's kind of going to come through the arc of the whole talk. Well, here's how it kind of started. Alex Orsa, he said he was going to come to this talk. I told him, I don't have too many pictures of Alex, but Alex took this picture. So this is me and Klaus. I don't know if you can see, but anybody who remembers. So yeah, and so I lived to tell, like I lived through however many Red Bulls I was drinking there. I don't do this anymore. We also had some fun. I actually found a picture of Alex. So it was at my 30th birthday party when I still had hair. Okay, so speed tests. Okay, so this is kind of where things started, right? Working late nights in Klaus, thinking about speed tests. Here's the thing about speed tests. I won't run this experiment with you today because we don't have time. You can sit there and do it as I talk if you want. But what I do actually in my class when I talk about these kind of things too, in some talks, is I say, take out your phone. If you've got speed tests, run it. You have a way of running it, like run it. Okay. Sometimes like enter it into a Google form. Tell me the number you got. What number did you get? What number did? And basically, like this is one that I did in some class that I teach, and some people got like close to 0, and other people got up to like 80, 85. Right now, the point here is not like the actual numbers that we're getting in this room as we might run this test, but the point is that like going back to that simple question, right? It seems like, oh yeah, there's a network. I can basically measure how many bits I can push across the wire in a fixed unit of time. This should be easy. This is like some fixed quantity. And no, like even in basically the simplest possible scenarios that we can sort of think of, you just get numbers that are all over the place. And there's a whole bunch of reasons that vary that I'm going to talk about next. But this should sort of we're starting to kind of peel the layers of the onion back. It's like simple question, actually not so easy to arrive at an answer that, not only we understand, but also we could maybe do something with. So this is kind of how it started. We started to ask questions about like access network performance, right? How well do these networks perform? We built some stuff. I'm going to talk about what we built. And then we did it in a bunch of different places. We also looked at the home network. Is the home network ever a bottleneck? The answer is the answer is yes. Now the answer is still yes. So I'm going to talk about a couple of things there. I'm not going to talk so much today about usage, but that is something that we were also able to look at. This is this picture of Srikant. You can see I had to put a GT logo in the talk. So there it is up in the upper right. This is Sri. He was one of the first PhD students who worked on this topic. Now he's now at Facebook, now Meta. So yeah, there he is locating throughput bottlenecks in home networks. So yeah, we started this way back when, asking some of these questions. It went pretty well. Okay, so we got short time. I don't have time to talk about like all these different papers in detail. But as I mentioned, we basically did some work like looking at access networks in different countries. We built a platform. I'll just mention a little bit, which actually to this day we're now using a new version of that to look at what's going on in this country right now as far as investment in internet infrastructure. There's $43 billion being spent by the federal government on this now. And a version of what we built in 2011 lives on to today. We looked at measuring application performance bottlenecks. So this is going to come back later in the talk as well. First question that came up was like, hey, I think at some point your web performance stops getting better as your internet gets faster, right? Okay, the answer to that is yes. And that question is going to come back. And this is a paper we wrote back in like, I think 2015. Is your home network the bottleneck or is it your ISP? The answer then was like, it's your home network. We actually just did another paper this year on that using different methods, same answer. this continues. So these are kind of some of the more recent kind of things and how this has been evolving. Here's the latest, Wi-Fi paper. Another one that I'm going to talk about a little bit later is like, there's different ways to measure speed, right? And up until just like last year, nobody really understood like how the choice of tool and how the infrastructure you chose to measure speed would affect the conclusions that you draw. So we've been doing some work on that. And another question that's been coming up a lot that I'll talk more about in the last like 10 minutes of the talk is how this relates to, social, political, and policy related issues. And one of the things that people became interested in like pretty recently is like, oh, I got a data set and I've got IP addresses of people who've conducted measurements. Can I put them on a map? Right? And the answer there is, well, it depends. Okay. Again, could spend the whole hour talking about any of these, but I guess the point here, before I kind of dive into more detail on specific things, is that simple question has been really rewarding. It's kind of kept me going, still keeping me going these days. Okay, so surprise to us, to me at least, was that measuring internet speed is actually pretty hard. So this was a paper that appeared in 2020. I wrote this actually with Jason Livingood, who's a senior VP at Comcast. You can imagine why Comcast was pretty interested in having this point raised. I'll get into it a little bit later in the talk, but it relates a lot to policy, right? You can imagine if you got like bad data about like the speeds people have in a geography or from a particular ISP, there's going to be a lot of like sideways conclusions that get drawn. So this paper talks a lot about some of the issues that like we've encountered and some of the issues that have come up in other cases, both in the in the technical arena as well as in legal and policy arenas. I'm going to get into 3 or 4 of these in the coming slides, but the capabilities of the device you're using to measure, like could introduce introduce tweaks into your measurements. This thing, for example, how you've designed the test, right? Like, how are you going to push those bits across the wire? How are you going to measure like what you just pushed is another one. The path between where I'm measuring and where do I measure to? That's a technical question. It's also a policy question as well. The network environment, right? Am I measuring the Wi-Fi or am I measuring the ISP? Right? Depends. The test infrastructure, okay? Like how's the server against which I'm measuring, et cetera. Okay, there's other kinds of barriers that come up. Like I mentioned, we did this in some other countries. And they're like, oh, yeah, you're like NSF government funded. Like, yeah, some random US people like putting devices in my home to measure. Yeah, go away. You can even imagine this gets worse if you want to do things that involve capturing traffic to analyze, let's say, application performance. Okay, and then there's also a lot of different questions here, which I'll talk about towards the end of the talk, which I don't know all the answers to yet. But let me just sort of tease it for you a second. When was the last time you ran a speed test? I don't know, maybe when you like signed up for your ISP or like maybe when you're having a problem, right? So interesting sample. Okay, so let me talk a little bit more about a few of these and I'll kind of tie them to anecdotes to kind of show you like the stakes are pretty high. So here was a case where the New York Attorney General sued Charter over slow internet speeds. You may have remembered this. This was maybe 5 years ago. They got a pretty good settlement actually because as any lawyer will tell you, right? There's sometimes the facts are damning, and when you sell an access point and they can't support the speeds that you're advertising, that's not actually going to go well for you. But as aside from those damning facts, I actually was an expert for Charter in this case and actually learned some pretty interesting things about data that was being used to bring the case. So here was one, and there was a tool, it was a client-based speed test being used to conduct Eric Schneiderman. I don't know if people remember him before he got booted, but he basically said, hey, run a bunch of tests from like this web-based speed test or from your phone and like tell us what you're getting and submit them to this website. Thanks, and send us a screenshot if you will. And it's like, oh, this is terrible. Like here are these speeds up at like, you can't quite see this, but this is like 300 megabits per second speed tiers, and people are only getting like medians of like they're maxing out at like maybe 100 and et cetera. So this is you can kind of see like doesn't ever seem to get better than right about here. Now, what you can't quite see here, but I'll read it. It's 5S, 6, 6S, et cetera. So those are iPhone models. Okay. Actually, what was going on here was that some of these phones that are basically older, They didn't support 802.11ac. So actually the radio itself in the phone never exceeded 100 megabits per second. Oops. Ultimately didn't matter for the AG still basically was able to win on other points. But this was like a great, I think, example of something where it was like, yeah, you got to be sure of like what you're measuring, because again, in this case, a lot of the measurements were reflected by the limitations of device capabilities. So here was another issue. Am I going to see? Okay, that's what I want. So let me start down here. This was from like one of the first papers we wrote on the topic that I showed to you. So what this is showing, this is again a CDF, normalized throughput. So one, you can sort of think of like that's 100% against whatever the ISP is advertising. So over to the left, sorry, over the right is good. Okay, this means like you're getting most of what the ISP is advertising, and then median is like here, and 90th percentiles up here, right? Okay, and then you see like, okay, some of these triangles are way over here towards 1, so that's, multi-threaded HTTP. What's that? Well, let me just, without getting into all the details there, that's how Ookla designs their test. Okay, this one here, which sort of caps out at about 70%. This is like opening up one connection between like wherever you're measuring from, and this one's opening up one connection. This one's opening up multiple. Okay, so intuition should tell you open up more connections in parallel. You should be able to push more bits down the pipe. That's kind of what's going on here. This was the test actually that actually has been used in various policy briefs, advocacy. Actually, in the New York Attorney General case, this was used as well. So again, you get a situation where it's the design and test of the tool. It actually showed up, in this map, right? Here's staggering discrepancy in Pennsylvania between rural and urban broadband coverage study finds. Except as you zoom in, you saw like, oh, Center City, Philadelphia, there's actually no internet access, or, it's like, well, actually what was going on in this particular case was like, the tool that was being used was actually just spitting out bad data. This is not to say that there aren't problems. There are actually lots of problems, and I'll get to those. I mean, these problems absolutely exist. So not basically denying that here, but only to point out that if you're trying to basically make a case and solve a problem, you actually need to know where the problem is. And so this is a little bit foreshadowing of like what I'll talk about later in the talk, but around the point in the pandemic, we basically got past the argument that like access to good internet is a problem, right? Everybody sort of realized that when we all had to go Zoom from home. Some people just didn't have it. We're now to the point where it's like, okay, we've finally basically gotten people to accept that. Now we got to fix it. And it's like, okay, well, what do we do about fixing it? Well, this kind of test, it was problematic, right? We kind of knew that this was bogus, but it didn't really matter because we were just kind of trying to make the point that there was a problem. I mean, it mattered to me as a purist, but as far as like advocacy, it didn't really matter. But now we're to the point where it's like, well, this doesn't tell us anything about the problem. So we basically need to figure out how we're going to test a little bit better. Yes.
So the fact that if my experience is not good, is it the ISP's fault? That was the common understanding, is that right?
Yeah, and in the early days, it absolutely was.
But is it still kind of largely the case? Or?
I'm going to come to that. So I think the answer there is like it can be, but it's certainly a lot. It's complicated. Yeah, it's certainly. It absolutely can be. ISP visibility into the network is actually not great. Much worse than you might think. But there are other problems now. So I'll come to those. Actually, I'm going to talk about one maybe next. Not quite yet. So this was something that actually, this one's new, isn't it? There we go. This was a paper we wrote, like, I think it was only published last year. Okay. And this was something that, that actually, I just talked about how test design, like we kind of knew it affected data and conclusions, but finally after working on this for 10 years, we built a tool that basically was able to install and run these tools basically in parallel and run them in tandem and actually compare the numbers people were getting. So I think we were the first people to basically have a very large data set that had 3 or 4 of these speed tests running in residential like hundreds of residential networks, reporting back what these tests were getting in parallel continuously over time. So it wasn't like a one shot. It was like 24/7. We're taking these measurements, essentially in succession. And we saw like, oh, okay, well, here's Ookla. We've know speedtest.net. They're kind of way up here downstream. That's the one we think about a lot. And then here's this tool supposedly measuring the same thing that's getting like basically 30%. And yeah, so basically we filed an issue with these guys. It turned out basically, not to belabor this, but essentially they had memory allocation issues in their tool that were causing essentially bottlenecks in the ability, the rates at which they were out to push data out the socket. And so again, the tool was the bottleneck. Again, this tool was this blue one. This was the tool that was used in the litigation I mentioned. The tool was actually used to build the map I just showed. Nobody even basically knew that this was going on until 2020. Okay, so there's another thing to think about there, which is like the existing data that's out there. Hopefully, is getting more stale as people are using newer data. But this I think was interesting because the work that we did on the problem allowed us for the first time to run those kinds of controlled experiments, but it took us quite some time to get there. To your point, like, is it always the Axis ISP? So I'm still on problems of measuring the tools. So this was a particular case back in 2013. Some of you may remember like the Comcast and Netflix were having a thing during that time. I think Peter maybe remembers that pretty well. So this was a situation where a group put out something that showed like, okay, here's basically median throughput, so that's just speed, achieved by Comcast, Time Warner Cable, Verizon, New York City. Okay, let me just stop right there. Boom. Read the rest later. And then you're sort of like, okay, things are good. And then like, kaboom, it's like really bad for months and months and months. So like, this is a bad situation, right? This is like persistent congestion. And there were lots of things. So there were lots of things going on during that time. I'll get into one of them on the next slide, which was really a surprise. But in this particular case, it was not the link from you immediately, into Comcast or AT&T or whoever your upstream was. It was elsewhere in the network. Now the question is like, where was the elsewhere? Actually, it was in a lot of different places. It was like where Comcast connected to Netflix. It was where, at the so-called interconnects. But this particular case was interesting because of the way the tool was designed and what they were measuring. The path actually went across this. Yeah, this was it actually went across an intermediate ISP called Cogent. I think actually Georgia Tech might still buy service from Cogent as a backup provider. They are famous for basically undercutting their customers. Undercutting their competitors and under provisioning. And so essentially what was going on here was that graph I just showed you, it wasn't measuring Comcast or whatever was on the other end. It actually turned out to be measuring Cogent. So you can see basically something that was written in a report here. Like we can infer that the performance degradation is interconnection related. Well, actually, that meant like we can infer that the performance degradation was between like Comcast and Netflix or whatever. Well, not quite, because if your path went through Cogent and Cogent was doing Cogent things, that's actually not what you can infer. So yeah, I'll skip that, just the details there because I want to get through the talk. But there's a bunch of different scenarios and like, what are you measuring? Are you measuring this link? Are you measuring? You're comparing between those? Are you measuring an interconnect? Are you measuring something inside the ISP? There's a whole bunch of things without knowledge of the path that you don't really know what's going on. Turns out the people who wrote this report didn't really know what was going on. And in this particular case, it was more than just Cogent being congested. It got fixed. You saw it went back up, but it wasn't a provisioning fix in this case. It said, this was Hank Kilmer, who I don't think works at Cogent anymore. He posted on a public list, due to the severe level of congestion, et cetera, Cogent implemented a QoS structure, et cetera. Cogent prioritized based on user type, putting its retail customers in one group and wholesale in another. So basically, they're doing funny things with how they're queuing traffic. Eventually what happened was, because the test traffic had a certain marker on it, they basically just started prioritizing the test traffic. So the issue wasn't fixed at the end of that plot. It was basically just Cogent figured out how to game the test. I'm going to skip this particular plot in too much detail, except to sort of emphasize, because it comes back. We did a study, as I mentioned, overseas in South Africa, and this is one basically where we first, you hear about these, how the interconnection or the path. I just gave you an example of how that could affect performance. Here was another case. We looked at basically latencies to major service providers. I think this one was to Google at the time. And you could see these are basically distances, sorted by geographic distance from Johannesburg, South Africa. So if we're thinking speed of light, you would expect latency, right, to go up and to the left. But that's actually not what's going on. You can kind of see, well, it goes up, but then it goes down, right, and then it goes up again. So what's actually going on here, right? So you can see this is that latencies to certain parts of the world from this place, right, or actually twice what's going on here. Well, what's going on is basically traffic from Johannesburg to Brazil, India. It's actually going through Europe. Okay, so this is I mentioned this just to kind of make that point that the path, the interconnect actually matters. Again, I'll run out of time if I get into too much detail on this, but this is like really, really an issue that is where tech meets policy, because it's like, what are you measuring, right? Are you measuring just the speed into Comcast? Are you measuring the speed across the network? Or am I measuring the speed to Google? Am I measuring the speed to my Zoom connection? Well, all these factors, path, et cetera, they come into play. Remember that question, why do we care? It's about lived experience, right? So that's where this thing actually gets really interesting. Lest you think we did that in South Africa and this couldn't possibly be an issue in a place like the United States. I just pulled this article 2 days ago. So BEAD, the Broadband Equity Access and Deployment Fund in our current administration, is $43 billion being spent on building infrastructure in this country to improve connectivity. A lot of it is laying fiber in the last mile. But this article actually just makes the point, right, that in rural areas, right, they're physically further from these exchange points where ISPs interconnect, just like I showed. And so we're getting, right, without an attention to this issue, we're getting a local version of this in the United States if we're not careful. So I haven't worked specifically on this issue, but this is one that I think certainly would be interesting to pay more attention to as we go forward. Another issue that comes up, as I mentioned, is that the Wi-Fi actually can be an issue. This plot shows so I'm not going to get into the details of how we built this test at the time because it was a monster. But essentially, what this shows is on the x-axis, the fraction of time your ISP is the bottleneck, and then on the y-axis, the fraction of time that your Wi-Fi is the bottleneck. And so up here, Wi-Fi bottlenecks, over here, ISP bottlenecks. And the size of the circle is the throughput we measured from your ISP. As you would expect, the bigger circles are kind of up here, right? Your ISP can push more bits, so your Wi-Fi tends to be an issue. Question was, where was the inflection point? Well, this was 2012. So that inflection point was around 35 megabits per second. That was relevant at the time because people were buying access speeds above that. But, things have changed, ISPs have gotten faster, Wi-Fi radios gotten faster. So we did this study actually again, just this past couple of years, and we were able to actually do it a little bit differently. We built a browser extension, and then we put a speed test server in the home. So we were measuring from the browser to your wall jack, and then we did another speed test from the wall jack out, and then so this would show this is what you're getting from the wall jack. This is actually my house, pretty good. I think at the time I had a gigabit service. Not so good, 32 megabits per second. That was probably not very, not in a good place in the house or something else. But this is exactly the point, right? And again, you can see the same conclusion. I just copied this from my slide, from 10 years ago, right? So as you're measured, we've added some zeros, right? Since 10 years ago, but the same conclusion, right? It's well, I've got faster access speeds, but again, if I've got 800 megabits per second from my ISP, almost all the time, the Wi-Fi is the bottleneck. So again, it's what are we measuring? And as we think about this lived experience question that I raised at the beginning of the talk, it's well, we've got a bunch of money being spent on improving internet access, lived experience. Well, we got to be real clear on where that problem actually is. Okay. So let's back up. So those are all the problems, right? At the time, I was well, okay, we got this really crappy data set from France, and like, there's this other stuff going on, like, there's people measuring from, their laptops and stuff. There's a bunch of garbage data. I think basically what we should do is go into the home router and like put a speed test on that. Cause like then we're like right there at the wall jack. It's always on. We're not like only getting things when people are upset. Big con, which I think, in the age of Docker, we're sort of like getting past this one, but still, you've got to get in there somehow. You've got to basically deploy it. So this was actually a major undertaking at the time. We put our software on firmware of home routers. We basically were flashing Linksys devices and throwing them out in the field. We got pretty good data set at the time, but this is like sort of what things started to look like. You could see at the time, I mean, this is why you want to be measuring it all the time, right? This is not good, by the way, this high variability. Now we see homes that look like this. We also see some that are straight. This is, and coming to policy issues of broadband labels and metrics, none of them reflect this kind of thing, right? The variability that people see. So that's actually another active issue right now. Okay, so we built a thing. We put it around the world. It was pretty good. I would say that this sample is it's nonsensical at the moment. As I speak to you in 2023, but like 10 years ago, it was pretty cool. I think we basically succeeded in getting like a bigger data set of broadband measurement from around the world than like anybody had. Okay, so we built a thing, right? We measured some speed, but like really, have we solved any problems? And like, as time went on, like 2015, 2016, I've been working on this 3 or 4 years, and I was like, okay, well, what is speed? What does that really have to do with anything? And actually, this was credit. I should have put a picture of Walt Johnston at the FCC. He actually posed this question to me as he was thinking about it. Like they have this program called Measuring Broadband America, and he said, I actually think like there's a point in time where your internet speed gets faster, but the web, like the speed at which your pages load, like they just don't get any faster. And that is absolutely true. The issue, I think, as all of us can appreciate as computer science, the issue is latency, right? Doesn't matter like how fast the pipe is, right? Doesn't matter how many lanes you put on the connector. It's still going to take you, 3 hours to get to Buckhead at 6 p.m. or whatever, right? It's like there's more cars on the road or more bits in the pipe than the pipe can support. Then it's a throughput issue. But it doesn't matter how wide you make the thing. It's still like, okay, at 5 a.m., it's still going to take you 20 minutes, right? And that's basically what we see, right? It's like, okay, page load time really stops improving beyond a certain point. This question comes up again in a number of cases. So this was web at the time. Comes up in the case of streaming video as well. So Kishore is not here. This is Kishore's daughter, Shalini Ramachandran. She's a reporter at the Wall Street Journal. She basically came to me. So Walt came to me like 5-6 years before that, asking a question about the web. Shalini came to me and she said, we've got like all these people like calling us saying like, they call their ISP and they say like my Netflix is terrible, and the ISP is like, well, just upgrade, and then it'll be fine, right? Which you can see incentives basically align to do that, right? It's like, yeah, just pay us more money and it's like all gonna go away. And so the question that came up at the time was like, yeah, like should you really be like getting faster internet? Is that gonna solve your problems? Or is your Netflix like still gonna suck with the faster connection? We kind of knew like intuitively, like you can look and see like, well, Netflix doesn't require 300 megabits per second, right? So like surely the answer is yes, but how do we show that? And so this was a really interesting project. Took us like maybe 3 years to do this, and I'm going to talk about why in just a sec. But yeah, ultimately we ended up on the front page, which I thought was pretty cool, and it was really fun to work with the Georgia Tech offshoot, I should say. Did she go to Columbia as well? I'm trying to remember.
She went to Emirates. So I was in the hospital when she was born.
Oh, okay. Well, she looks a little different now. So here's, so I'm going to talk about application measurement in just a second, but just kind of a segue, right? Moving beyond speed tests and that like lived experience question, it's like, well, measuring speed started to get really hard, like around 2016, 2017. You know, the networks were getting faster. And so that means like in order to fill the pipe to ask this question of like how many bits you got to push across, you got to push more bits. A lot of devices, a lot of things like are not able to push the bits. And so it's no longer your ISP, not only is it no longer your ISP, it's like your Wi-Fi or your iPhone or some server, but also you can't even measure it. It's like just like you got to basically build a ton of infrastructure to push those speeds. And then the question is like, does it even matter? Like, do we even care, right, about getting this really high number on the speed test thing on my phone when like Zoom sucks, right? And so we built a thing.
I should ask my question.
Yeah.
ISP is the only thing I pay for, isn't it?
That's right. That's right.
I don't pay anybody else.
That's right.
Who would I blame other than?
That's just it. It's like and actually this is, I'm going to talk about businesses later. We can talk about startups, but actually it's a cost center for an ISP, right? Because they get the calls no matter what, right? They also get the scrutiny as well. But maybe for good reason, right? They're the ones selling to consumer. But so no matter what, it becomes the ISP problem. Okay, I'm going to skip that. So we started to ask this question of like, how well does the network support applications, right? Because and this is the paper that came out of the question that Shalini asked us. Because intuitively what you want to do is like, cool, we'll take a speed test and then we'll look at like application quality. We'll say like, oh, how is, you know, how good is Netflix? Right. And then you would want to see that go like up and to the right. And then like hypothesis at some point is it stops getting better. Right. Except the x-axis we knew how to measure. We'd spent 5 years like, you know, thinking about how to measure speed, but we didn't know how to do the y-axis. Right. Like how do we do Netflix quality? And actually we were interested not just in Netflix. She was interested in Netflix, Amazon, you know, Twitch, Hulu, et cetera. We're like, oh gosh, like we don't even know how to do one of those. Maybe we can look passively at the traffic going through the network. And then again, I'm not getting into all the details here, but if you could see the video protocols, right, you could see certain things about like the resolutions of the streams being pulled, the frame rate, et cetera. Problem is, it's all encrypted now. Okay, there is security in this talk. So in this case, encryption, you know, ruins everything. So so we couldn't see the QoE metrics that we needed to see, and so we were like, okay, well, now we're gonna have to build something that's able to look at encrypted traffic and infer qualities of that video. Okay, so what do we care about? We care about things like how fast does the video take to start playing? What's the resolution? Does it ever stop? And is it switching? Because that's annoying too, right? You go from really high quality to low and back. That's also annoying. So these are the target metrics we tried to basically infer, right? Okay, so there's machine learning in the stock in just a second, but those are the things we're going to basically try to infer, right? But we're just looking at traffic. So the challenge here is that the traffic is encrypted. You see basically rates. You just see traffic rates over time, okay? So what are you going to do and this is, you know, you got different sessions like all mixed up in here as well, you know. So there's a bunch of different issues that again, like in the next 5 to 10 minutes, I won't be able to unpack for you, but just to give you a sense, first of all, I'm going to talk about one. You got to figure out that it's Netflix traffic if that's what you're interested in. That one turned out to be easier at the time. It's harder now, which I'll talk about in a sec. Once you've identified the Netflix traffic, you got to identify sessions. You might think like, well, that's maybe easy, right? Well, no, because there's, you know, anybody knows who's gone to Netflix, like stuff starts playing the minute you open it. And like, is someone actually watching a video? And, you know, which of these streams are actually the movie, right? Is another thing. Then you know, once you separate out the sessions, then you can start to ask the real question you're interested in is like, what's the quality of the session that I'm actually watching? Okay, so I probably don't need to go through this with this audience, but this becomes a machine learning problem, right? So we basically want to think about like what data we're collecting, right? How do we featureize it, right? We got to clean it. How do we basically pull features out of that traffic that we're observing in ways that basically allow us to build a model where our target predictions are those 4 things I talked about, and then the features are those things that I can see, which, you know, would appear initially to be not very much, but is actually more than you might think, and it's actually more useful. I think I see the issue is that this thing has limited range. Okay, so a lot of questions we had to come think about, right? At what granularity do we care, right? Are we second level, minute level, et cetera, whole session? Yes.
So I think so have you noticed that I mean I run speed tests all the time?
Yeah.
I know the AT&T, the whatever the router they gave us.
Yeah.
Issues with uploading traffic.
Yeah.
Uploading speed is always a third of what they advertise.
Yeah.
Trying to figure that I need 10 of their security module. And so my question to you is that I try to understand why they will limit the uploading the speed of uploading the upload traffic. If they so cares about security so much, they should really watch the incoming traffic. That's what I worry about.
Yeah.
Goes in internet.
I don't know, actually. Yeah. In the case of cable, like there's very good infrastructure reasons why that's been asymmetric over a long time. For fiber, I couldn't tell you.
I think once they turn off that feature,
Yeah.
of course they warn you. I said I don't care. Turn off. Then it's all of a sudden it's this symmetric speed.
Right. Yeah. I'm not sure, actually. Yeah, that's a good question.
Yeah.
Yeah, I couldn't tell you right off the bat what the security argument is there. Yeah, so step one here was to like identify services. We did that with basically domain name system traffic. So, you can see like, okay, I've got like the way that the DNS works, I think this audience is probably familiar with, but your client looks up a name, you basically get an IP address back. We can map names. Now, first of all, we had to do that statically. We had to identify like, oh, what are the Netflix CDNs? What are the Amazon CDNs? So that was actually kind of a manual painstaking process. This, I think, looking ahead, especially with DNS now being encrypted, becomes another interesting inference problem, but we solved it kind of the easy way, just mapping IP addresses to CDNs with a static. And the next thing we had to do is basically figure out like, what are we going to extract from this traffic? Again, I won't go through all of these things, but like, you can get a surprising amount of, you can infer a surprising amount of information about those 4 features from things like your throughput, the number of packets that are being used, but also especially, as we'll see, you can identify segments that are being, like, okay, so this video comes actually in segments which span multiple packets, and those are spaced in particular ways. There's actually 0-byte payload packets that show up in between segments. So you can look at the traffic patterns, infer like, that's a video segment, et cetera. So then you get features at multiple layers that you can then use in your model. This is just a picture illustrating that. And then these I talked about, so I can skip through that. Okay, so I've got features, I got targets. Now I've got to basically train a model. So that is actually a big challenge. Because how do I get a model that has like these features and then like resolutions as, and frame rates and other things? So it turns out like those of people in this room probably know there's like keys you can hit and like Netflix and, these other tools which will give you those application level metrics. I forget the exact key sequence you hit. You can get it off the screen. Okay, so basically what we did is we built the model and trained it in the lab. So we used like a traffic shaper, right, to basically emulate a bunch of different network conditions, right, that would give us, the targets. Like, okay, let's just crank down the network in ways that would cause a rebuffer or a startup, high startup delay, or what have you. And then we basically measured all the things I showed you on the last slide. And then we basically built the model, trained using those labeled traces. We didn't know that this was going to work at all, right? Because most of us, some of us watch videos on our laptops, but like most of us watch them on like smart TVs or tablets or maybe even phones. And like we could only really instrument the browser in this way. And so we didn't really know that this was going to work. It turns out that model transferred pretty well. The other thing that actually we didn't know was going to work pretty well is that like actually a general model across all services actually worked pretty well. But we also tested like, hey, do you have to do this per service? As you would expect, it works better, but the general model works pretty well. As it turns out, you can see basically that, as you get above like 50 megabits per second, either in like what the speed the ISP is advertising, or what you measure like with speed tests, doesn't actually matter very much. And the same is true of resolution. There's a little, as you can see, there's basically a little bit of effect at higher rates, but it's the conclusion that you would expect. And then the reporters did their thing. One of the things that got me thinking, though, is that like actually not all features that went into the model were of equal importance, right? And not all of these things are equally easy to gather or measure. So in the limited time, I won't unpack this too much, but it actually got me thinking about model deployment, because most of what we did was purely offline. Okay, so that got me looking. Now what I'm doing, like as I stand in front of you today, is like, how do we basically get those models into deployment? That becomes like a very systems problem that we think of like called model serving, right? How do we basically get these models served in a network to get these kind of problems diagnosed in real time? As we know, like this, we started to use Zoom a lot a couple of years ago, and so we actually had the idea to repeat this question with Zoom, Meet, Teams, and WebEx, and we basically repeated the exercise there. Okay, so that was one challenge. One of the things that I'm working on right now goes back to that slide I showed about like the browser, instrumenting the browser and gathering the labeled data in controlled settings. So getting labeled data is hard. I think we basically all know about that. But one of the things that we're working on now is basically using new techniques and stable diffusion and control nets to basically do synthetic trace generation. This, if I had another hour and maybe a year to do the work, I think we can have another talk on connections here to security and privacy, because this is actually a topic that I think connects quite directly, because getting labeled traces, right? Like we did the thing in the lab to get it. Ideally, we'd be like, hey, can I go into your home and like instrument it and like watch, take some traces of you watching Netflix, and, then I get it like from your tablet and your phone and all that. Problem is privacy, right? So that problem comes up over and over again in these types of problems. I'd love to train a model with your data, right? But you don't want to give me that data, right? Like either because you're an enterprise and you've got proprietary things, you're an ISP, you don't want to share things, or you're a consumer and you don't want me in the home. And so what we're working on now is methods to basically train models using synthetic traces that resemble those that are the real thing, but actually aren't the real thing. So that's an area. Fast model serving I talked about. This is taking me on an interesting journey as well. Like, again, I don't have time to talk about it in the remaining time, but another thing that we're basically doing is we realized that actually lots of people have these problems. And so we're working on some commercialization efforts as well on those problems. So, but okay, to wrap up, I mean, in the last like 5-10 minutes, I'm gonna come back to this question, right? It's about the lived experience. And I'll tell you a story. So I moved to Chicago in 2019. And some of you may have seen the FCC broadband maps. I actually couldn't, they've like kindly erased the ones from 5 years ago because they were terrible. But you would get something like this, okay? Something effective like, here's what's available in your neighborhood, et cetera. And then they painted my neighborhood in Chicago, and they said, okay, yeah, you can get Comcast at a certain speed, like I think it was about the speed at that time too. And then I called, and I was like, okay, cool, I'd like to get some service. And they're like, sorry, we don't actually serve your neighborhood. Oh, no, actually they came. And then the guy looks up at the poles and he's like, sorry, can't help you. And I was like, no. I called actually Jason, the guy who I co-authored the paper with, and I was like, dude, what's going on? And he's like, they were like, we'll be back in 6 months. And I was like, no. Called Jason. They were there on Saturday, the next day. But they rolled 4 trucks, and then like, not pictured as my house, like 3 houses over here. And like, here's some dude. I actually learned how they string cables through trees with these like funny extenders, because I had to go 4 houses down. And I watched them do this. And they basically, as they passed all the homes along the way, they basically wired up all the homes to mine as well. But I was like, man, if this is what it's like in a neighborhood that's like reasonably well resourced, right, and it's not like a terrible neighborhood, it's right next to the university, then this map that like supposedly shows things that are like awesome all over Chicago has got to be wrong, right? So surely we can take everything we knew about like doing this over the last like 5 to 8 years and like do better, right? Can we basically improve that? So that's basically led to a center that I started at Chicago called the Internet Equity Initiative. This turns out to be like a really hard problem. This, by the way, I should call him out. This is Guilherme, who started here at Georgia Tech. As some of you may remember Guilherme. So he's been a partner in crime the whole way along. And also some of you might recognize Tarun Mangala, who was Ellen Zagura's PhD student who did a postdoc at U Chicago. What are we basically going for here? It's the lived experience, right? I don't need to tell you any of this because we all lived through it, okay? But internet's kind of important for participating in life these days, and a lot of people don't have it. There is something that our current FCC commissioner calls the homework gap, right? We've heard digital divide term, but you may not have heard homework gap, right? So that's basically like if school kids don't have access to the internet at home, they can't actually perform well in school. A lot of horror stories about that. This was pretty much lit on fire during the pandemic. I think we all remember that. Okay, great. So everyone thought the internet was going to melt down during the pandemic. It actually didn't. I've actually got another talk I could give on that. Actually, ISPs did a really great job provisioning capacity during that period of time, except these equity problems came to light. And actually, it was sort of a happy coincidence because that whole story I told you about signing up for the internet, that happened like 6 to 8 months before the pandemic hit. So I was already working on this, and then suddenly people are like, oh, this equity thing is important. So that was just kind of a happy accident. Let's hope that we don't have another pandemic. So I got to learn a lot about this issue and continue to work on it. And we're almost out of time. So I'll mention a few things we're doing in this area. Oh, right. Oops. Did anybody see that? I've got another slide on this in a couple slides, but this is a plot of Chicago, as you can see, shaded in a particular way. Speed test data. And for anyone who saw that is not allowed to comment, but like, is any guesses about like what this is showing? Anybody?
Chicago's richer than South Chicago.
Yeah, it definitely shows that. Yes, thank you. What's the metric in the plot? So it could be income. Actually, it could be anything, as you point out. But any ideas about what this one is showing?
Wi-Fi equipments.
Okay, yeah, that could be. So that could be good. Common answer I also get is like speeds, internet speeds. Oh, north side, faster, right? South side, poor side, slower. Well, actually, it's number of speed tests taken. So actually, oops. So I found this to be really interesting. It basically goes back to the whole problems with client-based measurement again, right? We talked about 5 different ones. So here's like another one, right? It's like, oh, we really want to make this case that like there's inequities, et cetera. But actually, there's not even data in the places that you need to help make that case. And I think one of the interesting lessons I learned first when starting to work on this was like, oh, when you've got infrastructure problems, like internet infrastructure, it turns out you've got infrastructure problems. Okay, it's not just the internet that's bad. It might be like power as well. It's also amenities, but it's actually worse than that. It's social infrastructure as well. And so like even getting, how do I get into those neighborhoods? I don't know. It turns out you go to churches. That's what you do. But you can't just basically walk up there and say like, hey, we need some data. Can you get it for us, right? It's like there is no infrastructure. There's no political infrastructure. There's no social infrastructure, and so that becomes an interesting challenge. We've done a bunch of work like with the city and developing open source software with communities in these areas. And by we, I mean actually not me, because there are people who work in those areas. My co-PI on this is actually a sociologist who works specifically on these kinds of topics. And even we have hired a second person who works on like explicitly on community engagement because it becomes a very important aspect. We've done a lot of work in this area. There's a lot, it's internetequity.org. You can learn a little bit more about what we're doing there. Here's one project that I'll just draw attention to because it's an interesting story. Can I go 5 more minutes or so? So we started meeting with the city of Chicago at the time, and this was 2019. And I think there's a lesson here, which is that I was like, hey, my lovely PhD students, I really want to work on internet equity. I think this is a really important problem. People are like, I don't know, is there like a research problem there? Like, is it just bad? Like, and I'm like, I don't know. I actually don't know. Is there like a CS research problem there? But like, probably. Let's just kind of dig in and find out. But literally, I just didn't know. And people were like, I don't know. So here's a question the city asks: what is the baseline internet performance level and speed that should be considered acceptable for remote learning? Well, so this is Shalini's question about Netflix, but now it's for Zoom or whatever, right? And I'm like, yeah, we can do that. Okay. So this didn't come from me. This came from, this came from someone who worked for the mayor's office. And out of that, we get a paper, in SIGCOMM IMC about exactly this topic. Like, what are the speeds that are needed to sustain, Zoom, Meet, Teams, et cetera? This point I've already made. Okay. This is basically number of speed tests taken in these different cities. This is a question I don't know how to answer yet, which is like, how do we build the sample? How do we build a spatial sample to represent speeds across a geography? Everybody would like to know, advocates would like to know, people who are spending $43 billion in our government would like to know, where do I spend it? How do I spend it? Except, how do you build a sample? Well, we know router-based testing, et cetera, is better. It's going to give you better data, longitudinal data, et cetera. Except going back to like the problem we faced in 2010, the infrastructure deployment is challenging. You can't put it in 3 million, 3 million, homes of 3 million people. So how do you sample? So we're still working on that question. I won't get into the details here, but it's interesting ways to basically sample neighborhoods that we're thinking about. I'll say one thing about this. This is on the south side of Chicago. This neighborhood up here, fairly upscale single-family homes. This neighborhood down here, multi-unit dwellings. So for those social scientists or economists in the room, we have like a regression discontinuity right here, right? So we're looking at basically, things you put close together, right, in a sample, you might expect to behave similarly. So how close can we put these before we start seeing variance? How close can we put these? And then where do we see interesting discontinuities? So that's one question that we're studying. Okay, so hopefully this was interesting and you learned a few things. But I would say, just to kind of step back about this whole thing, is I think it's been a really rewarding journey. Like, it started as a really simple question, like, hey, how fast is my ISP? It's kind of defined, going on 2 decades of my career. I continue to work on it. I expect that in 5 years, I'm still be working on this. You can see that over time, the specific questions that we've worked on have changed and evolved. Some of them become more complex, right? More nuanced, up the stack, more towards humans. So many things have changed, right? Access networks have gotten faster. We've got machine learning that does useful things now. The way that we use the internet has evolved a lot. And so I think this is really interesting, like for students in the room too, right? Is you can think of a question, right? And it's the same question. Maybe it's the same question. Doesn't matter if it's this area, right? Same question someone asked like 10 years ago. First thing you might think is like, what has changed? Maybe I should ask that question again, right? Because I've just been asking the same question over and over and over again, same question. And, more papers than I could even count, right? Just doing that. I would say hopefully more impact, right? So many things I think have also not changed, right? Particularly in the way that I approach the work, right? Is that you do not have to imagine problems, right? There are real people who already have hard problems to solve. So pick one that matters, right? There's plenty of hard problems to solve. Pick a hard problem that if you solve it is going to make things better for other people. I'm maybe this is my bias, but there's a lot of work out there in networking, security, et cetera, that doesn't do real world deployment. I actually think that the research is nothing without that. Everything changes when you take something from the lab and you basically try to put it in the real world in front of people. And I, in my own work, I basically insist on this. And when I read papers, I take a huge lump of salt with anything that hasn't done this, because of course it's going to work like in the lab with your closed world training set in a controlled environment. Show me how it works in the real world once real people start interacting with it. That kind of brings me to this point, right? It's like so much of our field, I think, gets really caught up in the flywheel of writing papers. But the way that I've always thought about papers, the paper isn't the product. The paper is the thing that actually allows you to do the next thing. Now you have legitimacy, right? You're not just some random person with an opinion. You've actually done something that basically brings you evidence, brings you something that allows you to push out beyond just writing another paper. You can actually do something real now. And I think like all along the way, just everybody's got maybe a North Star. Hopefully you have one, right? But for me, it's always like, well, why am I doing this? I want to write a paper, right? I want to solve this smaller problem, but is that the right question? Well, going back, does this have anything to do with like making people's internet experience better in any, it could be anything, right? Helping operators, influencing policy. So if the answer is no, maybe consider it. And I'll say the last thing, I actually have one or two more after this, but most rewarding aspect of this has been all the people that I've had the opportunity to work with. Here are just a few of them. But yeah, no, I've had the opportunity over like the last 15 years to work with a lot of really amazing people who continue to teach me. This is my last slide. So I mentioned this already. I said, there are plenty of hard problems to work on. Really choose ones that actually make the world a better place. This first bullet, I actually can't take credit for. Actually, it came from Nick McEwen's Test of Time Award at SIGCOMM like 10 years ago. And it had an impact on me. I don't know how many people know Nick McEwen, but he's done a lot of really impactful work in the networking area. He said, there really does not need to be a conflict between an intellectually interesting idea improving the practice and advancing, I think I added the third bullet, advancing societal goals, right? And that means going beyond writing papers and do whatever it takes, right? Papers are certainly one important aspect of that, but there's so many other ways to improve the practice, and think about that as part of your work. I find the most rewarding aspects of this work have been the things that the papers have allowed me to do beyond that. So consider that in your own work as well. Thank you.
Nick, when you talk about deploying infrastructure, thanks.
I'm Hans Klein from Public Policy.
Thanks for staying a few minutes.
You try to, is it helpful to have leverage over ISPs? And do you know that you can get leverage over ISPs through local franchises?
Yeah.
Does that come up at all in Chicago?
Yeah, it does. I mean, I think leverage is incredibly important. I mean, I think governance, that's something you work on a fair bit, right? So I think I'm not expert enough to comment on all those dynamics. I will say that the power of incumbency is strong, right? You have basically Comcast, for example, who's got a pretty strong foothold in a lot of places, not entirely, shall I say, welcoming to new entrants, and yet, there are, if you look at I'm not an expert in this, I should probably defer to Peter, but if you look at things like rate of return, right, and like where an ISP stops making money, they're not going to go any further, right? So it's like we think about the rural, we hear about the rural internet divide, right? Like, well, that economics is simple, right? It costs money to basically deploy your fiber over miles, and there's one person there, so like forget it. But the same issue comes up in pockets of cities, right? An ISP may not go into a neighborhood where no one's going to subscribe to this because they don't see the need. And so you get this cycle. So leverage, I think, is important, right? Because there are economic dynamics there that I'm not fully expert in that actually create some inertia.
But I don't know if you're aware of this, and maybe the city people might have mentioned it or not. About every 10 years, the ISP has to renew its right to use city sidewalks or telephone poles and things like that. So and then the city extracts things, often access channels on the cable network.
Right.
But there's a possibility of that maybe they could require modifying the cable modems or something like that.
Right.
And so you get the citywide regulation.
Yeah, I should defer to other experts in the audience on those questions. I think that's a I see a lot of people who I think can even speak to that better than me. But I think I think the answer there is yes. Why, whether specific levers get pulled or not. I mean, obviously that power dynamic goes both ways. The city does not hold all the cards in a lot of those discussions as well.
So your work in Chicago reminded me of a study I did in Camden, New Jersey, back in the mid-90s.
Mm-hmm.
And it was all about universal service, only it was voice telephone service back then.
Yeah.
And we discovered some very interesting things by actually going into the neighborhood. One of the things I'd like to say is, could we stop using the term digital divide? Because there's nothing digital about it. It's all about wealth, right? It's about the distribution of household wealth. And so you have almost a straight linear line between household wealth and the penetration of communication and information technologies across the board.
Mm-hmm.
And sometimes, there's a dynamic in which we say, oh, the solution to that is to subsidize the technology, right?
Right.
But in fact, it's, the inequalities are more fundamental, and the subsidies end up pretty much being industry subsidies and locking you into a particular generation of technologies.
Yeah, I mean, your question in there is, could we stop using that term? I mean, I think so. No, I think you're right. But the point you make at the end of your remarks, I think is I mean, I share your viewpoint on that, which is that, like, again, this is a little bit outside of my immediate expertise. So I'm commenting as more of an observer, but we will observe that, like, a lot of the movement in these areas come in the form of subsidies, right? The America Connects program, right? In Chicago, there was Chicago Connected, et cetera, which is basically a subsidy to Comcast, right? To basically offer lower cost or no cost service into these neighborhoods. Well, you're basically further entrenching the incumbent there. And again, I think these are issues that are probably more in your realm than mine, right? But I think, I mean, by that, I mean the policy and social sciences realm, because you know, as we know, the FCC is made up of a lot of people who go in and out of industry
But it is
and
great.
also are somewhat captured as well in these spaces as well. And so I think there's a lot of political reasons why subsidies are what we end up with. Not to mention that it's a lot easier than drilling down on what's actually what the actual problem is.
Well, I just want to say that the measurement work you're doing really does contribute to the trade-offs and the policies they have to make. It's really important. I really like what you're doing.
Yeah, thanks.
I just have one more question on that.
Hey, I'm Eric Greenlee. I work with Ellen Zagura. I'm her PhD student.
Say hi, please.
Yeah, I will. Kind of building off that last comment. Do you see any technical, I don't know, shortcomings to switching to a utility model? Like you talked about how we kind of realized during COVID that internet access is, should be more of a right. Everyone needs it basically. Do you see from switching to these private companies to utilities? Do you see technical drawbacks or opportunities there?
That's a good question. I'm glad you put technical in there because there's certainly legal and regulatory considerations too in that kind of situation and tax situation as well. From a technical perspective, I'll just stick in my arena here and say that I think one of the things that we would need to think about, and we're going to see, I think this is going to come to light as the BEAD funding plays out over the next 2-3 years. But to your question as well. Well, if it's a utility or if it's something that basically the government wants to see return on investment, we're going to basically have to figure out, like, is it working? And how do we measure whether or not it's working? And I mean, I think that sort of underscores the entire talk, which is like, how do we what data do we need to figure out whether it's working? For who? Okay. When? So everything is wrapped up in that. It's like, well, is speed test enough? And then like we can go back to the 10-year-old argument of like, do I do 1 thread or 4 threads or 6 and then speed test to where? Like, am I measuring into Comcast or am I measuring to Netflix, right? Well, is it speed test or actually is really what I care about is, my Netflix or my YouTube performance or Zoom performance. And then, well, when? And then it's like, for who? It's like, was it for me? Like one person complains and that's like an issue? Or am I interested in saying what that looks like across the city of Atlanta or across Chicago? And that last question, I think, I don't even know how to answer yet, but it's going to be really important, in a utility model, for example, even in the BEAD situation that we're looking at is someone's going to want to know, we just spent a bunch of money to like improve things in neighborhoods that are unserved or underserved. And did it work? Right. And so certainly, we're going to see some data that says it worked for the people who want to see that it worked, and we're going to see some other data that says it didn't work so well. So I think for us, as computer scientists, right, as scientists in this area, I think there's never been a more important time for people like yourselves to be thinking hard about those kind of questions because people are going to be coming at it with all sorts of agendas, and the ability to look at it with like a clean lens. Is both technically hard and extremely important.
Thank you, Nick.
Yes.